Lesson 4, now we're going to look at the quotient rule. The quotient rule is used when I'm taking the derivative of two functions that are being divided. So I'm going to give you, it's very similar to the product rule, a little more fun actually. If I have a function on top and a function on the bottom, so I have one function that's being divided by another function, I'm going to call them hi and ho again because it's fun. If I take the derivative, the rule is I take the denominator and leave it the same. So I have ho times the derivative of the numerator minus the numerator times the derivative of the denominator. And all of that is divided by ho. See, fun to say and fun to do. Also known as ho squared, okay? Or the denominator squared, any of that stuff. So here's your quotient rule. Ho d hi minus hi d ho all over ho. See, it's so much fun. Let's practice. If I give you the function 3x plus 7 divided by 4x minus 3, I'm going to call the top hi and the bottom ho. So when I take my derivative, I've got ho d hi minus hi d ho all over ho, which is really just 4x minus 3 squared. Now it's just a matter of distribute, combine like terms, simplify your answer. So y prime becomes 12x minus 9 minus 12x minus 28, all divided by 4x minus 3 squared. 12x cancels, and y prime becomes negative 37 divided by 4x minus 3 squared. And that's it. Let's try one more. If I give you y equals 3x squared minus 4 over 4x plus 1, and I ask you to find the slope of the tangent. Well, what does that mean? When we are finding the slope of the tangent, it's just another way for me to ask you to find the derivative. I have a quotient here, so we need the quotient rule. Y prime equals ho d hi minus hi d ho all over ho. What do you think? Not so bad. We're going to distribute, combine like terms, and call it a day. Not really, we have one more problem to practice. When I distribute 24x squared plus 6x minus 12x squared plus 16, all divided by 4x plus 1 squared. Let's combine some like terms here. And you've got 12x squared plus 6x plus 16 divided by 4x plus 1 squared. And that's it. You're done. Isn't it great? Okay, one more problem, which is a little different. We're going to actually use the product rule in here. So hopefully you guys remember that. I really like these problems. I'm going to give you some information here. So I'm going to tell you that f of 3 equals negative 2 and f prime of 3 is equal to 4. I'm going to ask you to find g prime of 3 if g of x is 3x squared plus 5x f of x. So now what this means, I have given information, I'll have to use that at some point, and I need to find the derivative of g so that I can then sub in 3. So first let's get that derivative. G prime of x is equal to 6x plus. Now here's where you have to watch out. I have 5x times f of x. This is going to require the product rule because I have two functions that are getting multiplied together. So here's my product rule. Hi d ho plus ho d hi. Notice what I did. F of x is my first function, or I'm sorry, 5x is the first function, f of x is the second. So first times derivative of the second plus the second times the derivative of the first. Now we're just going to find g prime of 3. So now we have to sub that in and see what happens. 6 times 3 plus 5 times 3, f prime of 3 plus f of 3 times 5. Now this is where all of that given information comes into play. F prime of 3 was given to me at the beginning of the problem. So this becomes 18 plus 15 times 4 plus, and then f of 3 is negative 2 times 5. Now we just have to simplify everything. I've got 18 plus 60 minus 10. Therefore, g prime of 3 is equal to 68. What do you think about that? It's good stuff.